Hey, hello, geometry friends. We are off to section 1.6. This will be the video for our notes for the midpoint and distance. And the full title is Midpoint and Distance in the Coordinate Plane. Um, but again, revisiting midpoint and distance, and then we'll be using our graph paper that I've asked you to do all your work on. So today will be your first chance you'll get to do your XY axes. So exciting stuff. Let's jump right into our definitions. First definition is that coordinate plane. So what do we mean when we say the coordinate plane? And they used to call this, or it's also known as the Cartesian plane. But as the definition here says, it's a plane. So it's a two-dimensional surface divided by a vertical x-axis and a horizontal y-axis with coordinates given as x, y. Okay, so we should go ahead and sketch that out. And you've all probably done this before, but you have a vertical axis that's known as the y-axis, and then a horizontal axis, which is our x-axis, which actually, if you probably just noted that my definition, at least I just noticed, and I apologize, is mixed up. So we want to say, I'm going to just swap these two right here. And that is incorrect. Your vertical axis is your y-axis, and your horizontal axis is your x-axis. So please forgive me. Take note, that's got that backwards. So y is always going up and down, x is always going across. And what that does is that divides it into four planes. They're actually called quadrants, meaning four. And you number the quadrants as so. The first quadrant is over here, where x and y are both positive. So in other words, if I'm positive 3, I would go to the right 3. And then if y was 1, then I would go up 1, and both of those points would be positive. Quadrant 2, you then just go counterclockwise. Over here, x is still positive, but now you've dropped below, down on the y-axis, and so y is negative. Quadrant 3 is over here, and now you are both negative on the x-axis and negative on the y-axis, and so they are both negative here. And then quadrant 4, finally here, and here now x has gone negative, but y has risen above the x-axis, and so it has become positive. So I'd just like to point out the notes, the different quadrants, and then of course which coordinate is positive versus negative. Also, we have the center of the Cartesian plane. This is the point. Let me just switch colors here. This is the point 0, 0. That's the bullseye or the center. That's known as the origin. So just some basic vocab related to the Cartesian plane or the coordinate plane. It's easier to say coordinate plane. And again, the way you navigate yourself is through this XY coordinate, telling you, first of all, the X tells you the horizontal direction, and then the Y tells you the vertical direction. Okay, so let's look at some of that in action. Well, actually, we'll just do some more definitions. Didn't need to probably ask this, but we have next definition is the difference between the x-axis and y-axis. And actually, maybe I do need to do this since I mixed it up in my definition up there. But the x-axis is the vertical axis. Let's see, and I messed that up again. I prepared these notes and I prepared them poorly. Switch. Okay, so the x-axis is your horizontal axis, and your y-axis is your vertical axis. The x-axis is the first ordered pair. Whoops, let me write that a little better. The first ordered pair or coordinate, as it's known. And then the y-axis is the second ordered pair or coordinate. Okay, so that you get, again, as we already saw, x comma y. The x tells you which way to move horizontally. The y tells you which way to move vertically. So if we had an imaginary coordinate of, say, 2, 4, or I'm sorry, negative 2, 4, the x would tell me to go back 2, 1, 2, and up 4. So back 2, and then 1, 2, 3, 4. So negative 2, 4 would be right here. Whoops, again, a little too tight. Okay, or maybe just do one other example. 1, 5. I did the coordinate 1, comma 5. That would mean I'd want to go horizontally 1 and then up 5. 1, 2, 3, 4, 5. Should be right there. Quick note on your classwork. Make sure you use the actual lines in your graph paper and make sure you count. It's okay if you count by 2s or 3s or something to save space, but make sure you use the specific lines. I kind of didn't do that great here. Make sure you're right on the line. Actually use the lines in your graph paper. Don't just sketch on quickly on top of it. Okay, so you got your x and your y axes. It allows you to locate points in a two-dimensional plane. Then we're going to need to remind ourselves what a hypotenuse is. A hypotenuse is the longest leg of a right triangle across from the right angle. So if we sketch a right angle, which has a right triangle, which has a right angle in it, okay, the hypotenuse is always this one that is across from the right angle and is always going to be the longest of the sides. So this is our hypotenuse right here. Okay, you could also note a lot of times it's designated with the letter C. That a lot of times the letter C denotes the hypotenuse. And we're going to see that's important in this lesson when we start talking about the length of lines within the coordinate plane. And actually that then takes us into the Pythagorean theorem, which is a way in which to solve the side lengths of a right triangle. And so you get this famous formula, a squared plus b squared equals c squared. And that just refers to a right triangle, like the one we just drew above, where the two legs, actually I'll label the one above, are a and b, and then the hypotenuse is c. So actually if I go back up to my drawing here, I may just go ahead and label these. The hypotenuse is the long one. This and this side, these would be known as the legs. Okay. So in this case, this is a formula that says if I square the two legs, add them together, and then square root them, then I would get the length of the hypotenuse. So for example, we'll just go ahead and do a quick example. I'll draw another right triangle, and let's say that the legs are 3 and 4. So how could I find my hypotenuse? How could I find this distance? Well, what I do is I want to just square the two legs, 3 squared plus 4 squared. That's like the a squared plus b squared equals c squared. So that's 9 plus 16. So that's 25 equals c squared. And then you say, well, what number squared gives me 25? Well, to do that, I would just square root this. So the square root of 25 is just 5. So I picked a nice easy one. 5 equals c. So this is 5 right here. That's how you basically would use the Pythagorean theorem to find that longest side of a right triangle. And you're going to see today we're not working with triangles per se, but in the coordinate plane, you're going to see, in a sense, how we actually are using right triangles. And you're going to use this a squared plus b squared formula to find certain distances. Okay. If in the event that something doesn't square root cleanly, I have no problem with using a calculator to just calculate what that decimal length is. Okay, so those are our definitions. The coordinate plane, and then hypotenuse and Pythagorean theorem. And you'll see why in a moment why we learned those. Okay, so question number 1 says, how do you find the midpoint between 2 points? How do you find the midpoint between 2 coordinates? Okay, so the first question is a review meant to trigger to show you how easy it is to then do it with the coordinates. So how do you find the distance between 2 points? You add them together. You take point number 1, you add it to point number 2, and then you divide it by 2. Okay, so you add them together and you take the average. Don't subtract them. We've kind of said that incorrectly in an incorrect quiz question. No, you add them. So if I have, let's just take a really simple example. If I take 3 and 5, let's put this over here. So if we were going to say, what's the middle between 3 and 5? Now you immediately see the answer, but that's on purpose so you can see how that it actually works. The middle is, of course, 4. But we would say, okay, so 3 plus 5 divided by 2, well, that's simply 8 over 2. So that is 4. Okay, so you just add, that's how you find the midpoint. You add the 2 points together and divide by 2. So what happens if you have a coordinate? So now say you have a coordinate And now, instead of having just 2 points, you actually have coordinates, 2, 3, and 5, 7. So what that's picturing is that's actually picturing a Cartesian plane where you've got 1 point. Let me draw my lines better, just like I asked you to do. Where you've got a point at over 2, up 3, and you've got a point at over 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So you've got these 2 points, and they form a segment, and we want to know, okay, well, what's right there at the middle? Okay, well, the key is to simply use what we've already talked about and do it for each term, the x and the y. So I want to find the midpoint of my 2 x points, and I want to find the midpoint of my 2 y points. Don't try to find the midpoint of 2 and 3 and 5 and 7. That would be a mistake. No, you want to find where horizontally is the middle and where vertically is the middle. So the way that I would solve this is I would say, okay, so 2 plus 5, again, because those are my 2 x's, divided by 2. And so that's going to give me 7 over 2, which is then 3.5. Okay? Then, so that means that the middle horizontally is at 3.5. 1, 2, 3. It's going to be somewhere right on the 3.5 line. Okay? So now let's find it vertically. So 3 and right here, 3 and 7. I can just do the work up here. 3 plus 7 divided by 2. Okay, that's going to be 10 over 2. So that means it's at 5. So the vertical midpoint is at 5. 1, 2, 3, 4. It's going to be right here. Okay, well, where do those 2 points meet? There and here. And what do you know? That looks like right about the middle of my line at, what are the coordinates? 3.5, comma, 5. 3.5, comma 5. Over 3.5, up 5. It's the middle of the segment on the coordinate plane. So again, all we did was our basic midpoint formula, but you do it with the x's and you do it with the y's. So if I was going to, let's see real quick. Okay. Try to define this. We could say something like this. It's the midpoint. Oh, let me go ahead and. The midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That is our midpoint formula. Sorry, I kind of ran out of room there. I had to squeeze it in. But that's what we basically did. We added the 2 x's together and found their average. We added the 2 y's together and found their average. And that'll give you, and you can always know you're right, because if you graph it like I did, you'll see that the point you find should be right in the middle of that line. So if you take your time to know whether you're right, you're guaranteed to get it. Okay, so then question number 2 is now, oh, good, an example. I didn't have to go through all that, but that's right. You get lots of bonus content here on geometry videos. So what's the midpoint of 2, 2, and 6, 8? Well, let's do it again. All right, over 2, up 2, going to be right there. And then over 6, down 8. You just count it out, 2, 3, 4, 5, 6, 7, 6, sorry, not 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Go down a little further, 8. So right here. Whoops. So we've created this segment, and we want to see, okay, where is the middle? And you could kind of estimate it, but let's go ahead and use the formula, and we'll see if it looks right. So we're going to add the 2. I'm going to just go ahead and write it again. You're going to add the 2 x's, and you're going to divide by 2, and that'll be your first coordinate. Then you're going to add the 2 y's together and divide by 2, and that'll be your second coordinate. So let's work it out. So 2 plus 6, that's, I'll go a little slower, but yeah, 2 plus 6. When you get good at this, you'll just do it in your head. You won't have to go quite as slowly as I am. 2 plus 6 divided by 2, okay, that's 8 over 2, so 4. So the first coordinate is 4. Now, let's go ahead and do the 2 y's. 2 plus negative 8. 2 plus negative 8 divided by 2, that's going to be negative 6 over 2. So that's going to be negative 3. So that would be the second coordinate. So the coordinate of the midpoint should be 4 comma negative 3. Well, let's check it out. 1, 2, 3, 4, 1, 2, 3. Okay, my line's a little crooked, so it may not look perfect. But yes, I can see that over 4 down 3 is right there. And that's about right there in the middle. So bingo. We have found our midpoint. Okay, so you'll be using that frequently throughout the semester. So keep that in mind. Don't just think, oh, that's complicated. I'll skip that part of this chapter. No, you're going to want this tool in your tool belt moving forward. So make sure you can find your midpoints. Okay, question number 3. So basically the two skills you'll be doing in this lesson are finding midpoints. And the second skill is for this question, and that is finding the length. How far apart are 2 points? What's the distance between them? And so this problem, we've gotten, it gives you 2 points. It says, how can the Pythagorean theorem, how can you use Pythagorean theorem to find the distance between 2 points? Okay, and so we've got 2 points here that I've gone ahead and just made up, negative 2, 1, and 3, comma 3. And so we could find the midpoint. That's what we just reviewed. But how about finding the distance between them? How long is that? How far is that? If this was a map and these were 2 locations, how far is it from point A to point B? Okay, well, the trick is, and this is why I mentioned the Pythagorean theorem, you want to picture these 2 points as the hypotenuse of a triangle. In other words, anytime you connect 2 points, you're going to get this diagonal line most of the time, and that has a horizontal distance going this way. Let me actually change colors. It has a horizontal distance this way and a vertical distance this way. And so immediately you could say, oh, that's a right triangle. And when you go horizontally, the distance between the 2 numbers is very easy to see because you're not trying to count diagonally. You can say, oh, okay, to go horizontally, it's literally, I could count it out. 1, 2, 3, 4, 5. So this bottom distance is 5. Okay, the horizontal change is 5. The vertical change is 1, 2. I'm sketching this out to illustrate it. When you get really good at this, you can just do that in your head. You can say, okay, the x points are negative 2 and 3. That's a distance of 5. The 1 to 3, that's a distance of 2. But anyway, so we see here, this is basically a right triangle with distances of 5 and 2. Well, then we just can incorporate our Pythagorean theorem. A squared plus b squared equals c squared. That means the 2 legs squared add up to the hypotenuse squared. And so the distance I'm looking for is actually this c squared. Okay, so let's go ahead and solve this. We just go, okay, plug it in. 1 leg is 5 squared plus 2 squared. It doesn't matter which one is a and b, so that's nice. I could do 2 squared plus 5 squared or 5 squared plus 2 squared. So that's 25 plus 4 equals c squared. That is 29 equals c squared. So be careful. Don't say the distance is 29 because that's the distance squared. So the actual distance would be the square root of this. And what this does on the right is that cancels it out. So we would get c equals the square root of 29. You could leave that as your final answer, or you can go ahead and grab a calculator, which I'm grabbing right now. And you can sit there and go, okay, so the square root of 29, and this is where you'll now have to round it, is approximately 5.4. So approximately 5.4, which that's more in proportion. You got a triangle with 5 here, 2 here. The overall distance has to be the biggest because it's a hypotenuse. That's going to be approximately 5.4. So either of these can be my final answer. Okay. But what we just did is we created the horizontal difference and the vertical difference as the legs of a right triangle. Okay, because the question asked, how do we do this? Okay, so I'm going to say the horizontal change, difference and vertical difference equal legs of a right triangle. Okay, so then the distance equals the hypotenuse, which I'll abbreviate. Okay, a little bit sloppy, but again, just trying to articulate the concept that when you see 2 points and you want to know how far apart they are, you can calculate by either drawing it or even learning to do it in your head. How far apart are the 2 x coordinates? That's the horizontal change. How far apart are the 2 y coordinates? That's the vertical change. And then plug those 2 numbers into your a squared plus b squared equals c squared formula. And then you can simply solve for what that distance is. Our last question will be this in action, but in word form. And this is where we have a baseball field in which you have the home plate, or all the baselines are 90 feet apart. So that means basically baseball fields are a diamond, or actually they're a square, where these distances are all 90 feet all the way around the base paths. And the question asks, how far would a catcher have to throw the ball from home to second in order to catch somebody stealing? Well, this is basically, you can see what we've just created. Here and here, we now have a right triangle. And the distance that the catcher has to throw is a hypotenuse, because it's the longest side across from a right angle. Okay, so this is just to help you practice your Pythagorean theorem. Okay, which again says a squared plus b squared equals c squared. The 2 legs of this triangle are 90. So we've got 90 squared plus 90 squared equals c squared. And this is where you're welcome to use a calculator. The numbers are going to be kind of big. We'll see what happens. So 90 squared, that's basically 9 times 9 is 81, but with 2 zeros. So 8100 plus, let's see, plus 8100, the same thing, of course, equals c squared. Add those 2 together, we get 16200 equals c squared. And now this is where I'm going to go ahead and use a calculator, because we're going to square root that. So what is the square root of 16200? 127.3. So approximately, so c is approximately 127.3 feet. Put some units on it. It's a word problem. And that seems about right, because if the base paths are 90 and we know we have to be longer, 127 plus feet sounds about right. So again, just another example of the Pythagorean theorem in use, which again, primarily today, you'll be using it like I demonstrated in problem number 3, where they give you 2 points. And let me just draw this at the bottom just to drive it home, because like I said, bonus content. If I have a coordinate plane and I give you any 2 points, let's just say I go 1, 2, 3, 4, 5, 1, 2, 3. So I've got this point 5, 3. And I pick another point that's back 2, down 3. So -2, -3. And I want to find what's the distance between them. Okay, anytime you do that, look what there is always a horizontal distance that you can quickly calculate, and there is a vertical distance you can calculate. And so you will always be able to create a right triangle in which to then use a squared plus b squared equals c squared. I really encourage you. We're going to be doing this a lot. You don't want to give up on it, and that's one reason I'm still talking about it, trying to help you get a better idea of what you'll be doing. But you're going to want to be able to find all semester long the distance between 2 points. And so you want to see how those 2 points always create a right triangle through which you can then use the Pythagorean theorem. All right, but for more help, we'll have a video on it with a couple selected exercises, or rewatch this one again, or look up Khan Academy for additional help, or by all means, please Zoom chat me and we'll talk through it together, because I am here to help. All right, 1.6, midpoint and distance on the coordinate plane. Good luck.